Good afternoon, Dr. Veronica.
Hello, Alessandra.
Hello. First of all, welcome to the Congress and thank you very much for your presentation. We appreciate it very much and it was very interesting.
Thank you. I am very grateful to participate in this event. Yeah, I found very, very interesting.
Yeah, and I have some questions here from the participants.
Okay.
All right. First one from Juan Aparicio. One question: Are there advances on other metals or toxic compounds?
Yes. Hello, Juan. Juan is a student from our university, so he is a well-known in our research group. Yes, we have developed several assays using another toxic pollutants. In this case, for this presentation, I focus on the pollutants present in groundwater, but we have a good experience in the removal of heavy metals and nutrients, which are species derived from nitrogen and phosphorus, which are very toxic in higher concentrations. They are present in some cases where the organic matter is abundant. So we have tested this kind of materials of nanocomposites, and we found efficiencies that maybe we can say that are comparable with the efficiencies that we found with arsenic and fluoride. The difference in such case was the water matrix. In such cases, the water matrix was surface water from rivers or lakes and marine water.
Oh, very interesting. And I have another question from Juan too. He's saying, hello everyone, I'm Juan Aparicio, I study in... Okay, he's talking about his work. We have a work presented at ClickLab in 2022 on arsenic and fluorine.
Yes.
Okay, I have also, that's pretty cool. I have a question from Nayara Milagres. What are the potential implications of combining multiple drugs within a single Oh, no.
No, but this is not from my lecture.
No,
I
yeah,
imagine.
the questions remained from the previous lecture. I'm sorry about
I
it.
imagine. Don't
Okay,
worry, don't
so
worry. It's okay.
I have the actual questions over here. It's just that it's the same questions part from the previous lecture. Okay. How do you ensure that the nanomaterials you create are eco-friendly and sustainable for long-term use?
In these steps of the research, we have implemented several cycles of reutilization of the materials, and we have proved that they are efficient and can be reused by at least 10 cycles, 10 follow with cycles without any regeneration step. So these assays were performed at laboratory scale. We are now developing assays in the same sense, but improving or incrementing the volume of water. So in this case, we are found that the number of cycles is reduced, but anyway, the materials could be finally disposed in an eco-friendly way, because their original compounds, their raw materials are all biodegradable. So it would not be a problem, the final discard of the adsorbent in this case.
That is really interesting. And I have another question here. Do you believe this technology will be available in the next future?
Sorry, I don't hear so much the question.
Okay, do you believe this technology will be available for everyone in the next future?
Yes, our idea is that these materials would be available for the rural regions to little populations in principle, and we are working on the transfer of this technology to an enterprise or an industry that would be able to scale up the fabrication of the materials, the nanocomposites. I believe that in the short in a short period of time, we can have available these materials just for rural or little populations use. The expansion of these materials to greater scale is dependent on our ability to transfer this technology to an industry.
Yeah, I think this happens with many other types of technologies too, to make
Yes,
available for the population.
this is always our challenge as a scientist. No? In our case, our research group is strongly oriented to the transfer of technology. We have some successful experience, but we are aware that this is a long a long way that we have to transit. But with this short intermediate results, I think that we are near to the to the application, to to put in availability these kinds of materials for the most part of the population.
Yeah, that's actually very promising too. And I have another question here. How do the materials that you develop compare to the current remediation technologies in terms of cost and accessibility?
In terms of cost, this kind of technology is sensitive, lower cost, because the biomass we employed is a residue which is massive in our country and in many countries of the world. So we not only are using a low cost raw material, but also we are adding value to a residue which is not employed to another ends. So the other component of the nanocomposites are nanoparticles, inorganic nanoparticles, mainly iron oxide and hydroxyapatite, which are very, very cheap, very easily prepared with procedures that don't involve high energy consumption, neither expensive reactants. So compared with the technology available in the market, we consider that we have developed small merchandising studies, and we found that they are lower cost than some available technology. But here in Argentina, we have not a viable technology to remove simultaneously arsenic and fluoride that be able to apply in small populations in rural regions where electric energy is required, for instance, or another kind of technology. So in this case, we have we have compared our nanocomposites with the more close materials that could function in the same way.
That's very cool. Also, another question here. What challenges have you encountered when testing your materials in real groundwater samples compared to model samples?
Yes, this is a very, very interesting question, because contrary as we can think, we suppose, we found more better results when we tested the materials in real water. I mean that in particular the stability, which is a point that in many articles, research articles, devoted to the basic studies, is not attended. The stability of the material is missing in many of the research articles we can find in open literature. So when we evaluated the stability, we evaluate in terms of the leaching of some parts of the nanocomposites. I mean, we evaluate the integrity of the nanocomposites. So we found that in distilled water, using model water samples, we saw that our materials were very unstable. We found leaching of iron and leaching of calcium in the case of hydroxyapatite. But when we tested the stability of our materials in real groundwater, we found, it is true, a slight fall of the efficiency because of the competitive effect of the species, different species, including organic matter present in water. But we found that the stability was better. The leaching of iron and of calcium was sensitively lower, was undetectable by atomic absorption spectroscopy, which is the technique we use to test the leaching of metals. So really we found very good results, and we encourage to researchers who work in this kind of topics that don't stop in the model size, that if it is possible to test their materials in real or in simulated real water samples, which is the result will be very, very interesting, and can be justified in terms of the interactions between the species present in the water sample. You have seen in the presentation that I named these nanocomposites as versatile, and this is related to this capability to be stable in different matrix of water from different regions, even when all the water samples that I presented in this lecture were of groundwater origin. These were from different regions in my country, in Argentina. So the composition was sensitive different, not only in terms of the pollutant of interest, that in this case were fluoride and arsenic, but also of the rest of the components of the water. So this affect in different measurement the integrity and the efficiency of the nanocomposites, and this is a point very interesting to study.
It is interesting how the model testing is always, and not always, has a complete coverage over what's going to happen on the real life tests. Yeah. So this was the last question. I think we are already run out of time. So would you like to add anything for the Congress?
Yes, I really want to thank the organizing committee. It was really a great pleasure for me to participate. I enjoyed various lectures and some presentation of posters, and I feel that it is a Congress of excellence. It is really, I'm proud that this kind of events take place here in Latin America. So thank you very much.
Thank you. We thank you also for your participation. It was a very interesting lecture. and it added a lot to the knowledge, and the people participating really enjoyed it. So thank you very much. And
No.
also I and I invite you all to participating on the next lectures and the final ending ceremony that's going to happen also today. So thank you all for participating on this Congress.
Thank you, Alessandra. A great pleasure.
Thank you.
My mail is in the chat of questions. If anyone want to contact me.
All right.
Bye-bye.
Thank you very much. Bye bye.